Hi, this is Algebra 2, Lesson 36. We're going to talk about contrived problems, multiplication of rational expressions, and division of rational expressions. We're starting on page 164. Okay, one of the things that any math teacher hears over and over and over again is, am I going to need this in real life? So here is the answer. Many people look at the kinds of problems we are working through and ask when they will need these in real life. These problems are contrived, that is, they're made up. So you can learn the skills that you will need to work with more complicated problems in more advanced math and science courses. And even in real life, if you end up going into a technical field or one that involves complicated measurements. The problems themselves may not have practical applications, but the skills and the logical thought processes needed to work them out are invaluable. I promise. So, let's talk about the multiplication of rational expressions. Of course, our rational expression is just an expression using ratios, which is it's a fancy word for saying fractions. When we multiply fractions, we just multiply across, right? So 3 times 7 is 21, 5 times 8 is 40. And then we look for something we can simplify. In this case, there isn't anything. Okay? If we're doing this algebraically, so we have letters, we still multiply across. xm times y plus 5. And of course, if you're in my class, you're not going to leave that in parentheses. We remember that fractions are multiplied by multiplying the numerators to form the new numerator and the denominators to form the new denominator. When we multiply polynomials, it is often useful to factor them first to see if any of the factors will cancel before trying to do long multiplication. We're going to multiply x squared plus x minus 12 all over x squared minus x minus 20 times x squared plus 2x minus 35 all over x squared plus 9x plus 14. Okay, we're going to start by factoring all 4 of these trinomials. Let's start with x squared plus x minus 12. We've got an x squared here. Since we're working with trinomials raised to the second power, we're going to end up with 2 binomials. We've got x squared, so we're going to have x and x. We see that this is negative and this is positive, so one of these is going to be positive and one of them is going to be negative. Now we need a factor of negative 12. We need factors of negative 12. They're going to add up to positive 1. Okay? The factors of negative 12 are negative 12 and 1, which add up to negative 11. We have negative 1 and positive 12, which is going to add up to positive 11. We have negative 6 and positive 2, which add up to negative 4. Or positive 6 and negative 2, which add up to negative 4. We have negative 3 and positive 4, which add up to positive 1. So we'll have a positive 4 and a negative 3. Because 4 times negative 3 is negative 12, but 4 minus 3 is positive 1. Alright, now we have x squared minus x minus 20. So once again, we have 2 binomials. We're dealing with x squared. These are both negative, so one of these is going to be positive and one of them is going to be negative. The factors, we need factors of negative 20 that add up to negative 1. So we've got 20 and 1, we have 10 and 2, we have 5 and 4. So negative 5 and positive 4 will give us negative 1. Okay, we're already starting to see a few things that might cancel. Good, so over here we have x squared plus 2x minus 35. We have x and x. This is negative, so it's going to be 1 positive and 1 negative. We need factors of negative 35 that'll add up to positive 2. So we have 35 and 1. We have 7 and 5. So we have positive 7 and negative 5 will give us a negative 2. Okay. Down here we have x squared plus 9x plus 14. This is an x squared. This is positive and this is positive, so these are both going to be positive. Factors of positive 14 that'll add up to 9. We've got 14 and 1 and 7 and 2. So we can use the 7 and 2. Alright, so now we have a multiplication problem. We've got x plus 7 and x plus 7 here, so those cancel. We have x plus 4 and x plus 4 here. You remember when we're multiplying, we can cancel from here and here also. So we have an x minus 5 here and an x minus 5 here. That leaves us with x minus 3 over x plus 2. And that's as far as we can go. These are not hard, but they take lots of steps. So take your time. Make sure you're factoring correctly and then look for things you can cancel. Now we're going to do division of rational expressions. So we have x over y all over k over b. We've done these multiple times. Remember, this is the same as x over y divided by k over b. And when we divide, we flip the second one and multiply it. That's the same as multiplying times the reciprocal. It's doing the exact same thing. Those cancel and we'll have xb over yk. Okay, we can use the same process to divide trinomials. Once again, factor the trinomials first to see what will cancel. So we have x squared minus 6x plus 8 over x squared plus 3x minus 28 divided by x squared minus 2x minus 15 over x squared plus 2x minus 35. Okay, so let's start factoring. We have x squared minus 6x plus 8. The x's are going to, x squared is going to turn into 2 x's. This is positive and this is negative, which means we're going to have 2 negatives here, because 2 negatives multiply to a positive, but they add to a negative. So we need factors of positive 8 that will add to negative 6. We have 8 and 1, or 2 and 4. 2 and 4 are 2 times 4 equals 8. 2 plus 4 equals 6. Or in this case, minus 2 minus 4 is negative 6. Alright, we have x squared plus 3x minus 28. So we'll have x's here. We have a negative here, so one of these will be positive and one of them will be negative. So we need factors of negative 28 that will add up to positive 3. We have 28 and 1, 14 and 2, or 7 and 4. So we have, it'll be positive 7 and negative 4. Okay, this is divided, which means we're going to flip these and multiply. So we can do that later, but we might as well do them now because we're going to rewrite anyway. So we're going to do this one for the numerator now. So we've got x squared, so that'll be x and x. Here's a negative, so this is going to be a positive and a negative. We need factors of negative 35 that add up to positive 2. I think we just did that in the other problem. We'll end up with positive 7 and negative 5. And when we flip this guy, this one will be the denominator now. So we have x and x. We have a negative 15, so one of these will be positive and one of them will be negative. We need factors in negative 15 that'll add up to negative 2. So the factors of 15 are 15 and 1 and 5 and 3. So if we have a negative 5 and a positive 3, then they will multiply to negative 15, but they'll add to negative 2. Okay, now that we have them all factored, we can look for things to cancel. So we have x minus 5 and x minus 5. That's easy. We have an x minus 4 and an x minus 4. We We have x plus 7 and x plus 7. That leaves us with x minus 2 over x plus 3. Okay? Let's do another one. We have simplify x squared plus x minus 6 over x cubed minus 2x squared minus 35 divided by x plus 3 over x squared minus 7x. Okay? Let's start simplifying. Here we have x squared plus x minus 6. That's a trinomial, so we're going to factor it into two binomials. We've got x squared, so it'll be x and x. This is a negative, so one of these will be a positive and one of them will be a negative. We need factors of negative 6 that'll add up to a positive 1. So we'll have positive 3 and a negative 2 all over. Okay, now we've got, that can't be right. There must be an x there. We've got x cubed minus 25. We have x cubed minus 2x squared minus 35x. So we're going to start on this bottom one by factoring out an x. Don't lose that x. X, that'll leave this with x squared minus, we're pulling out an x, so this will be minus 2x. And we're pulling out an x here, so this will be minus 35. Okay? Let's keep going. We're going to flip these. We're going to change this into multiplication and flip these. So this guy will be on top. We'll have x squared minus 7x over x plus 3. Okay? We've rewritten. Let's keep working. We've got x plus 3 times x minus 2. I really truly want you to write out all of these steps. Even if you can see ahead a little bit, write out the steps anyway. Okay? I'm not going to write that one yet. Alright, so now we have x squared minus 2x minus 35. Pretty sure we've seen this one again. Alright, so we've got a positive and a negative, because this is negative 35. Now we need factors of negative 35 that add up to negative 2. So we'll have a negative 7 and a positive 5. I think they were the other way last time. Alright, times. Alright, we've got x squared minus 7x, so we can factor out an x. And we'll have x minus 7 all over x plus 3. Okay, now we can start canceling. We have an x plus 3 here and an x plus 3 there. We have an x here and an x there. That's why we don't lose those. We can use them later. We've got an x minus 7 here and an x minus 7 there. So that leaves us with x minus 2 over x plus 5. Okay? That is it for that problem. That's it for this lesson. Show your steps. Take your time. Work out the factoring. Look for things that cancel. If you leave this in a non-canceled state, then it's not completely correct. Okay? So look for things that cancel. Don't lose little hangers on. And, yep, do them carefully. Try your practice problems in your homework. Let me know if you have any questions. Thanks!